We are John Alberti,
and Griffin Alberti.
And our company is Alberti Design. It can be found at violintools.com on the web. And I'll throw something in right away. The parent company, Windstone Editions, does the shipping and billing. It makes a completely different product. Figurines of my wife's sculpture. So that's a little bit confusing the first time you order from us. Most of you know us and know our tools, I think, but for those who don't, we'll go through the tools and show you briefly what they do, and then we'll produce some better videos that will show in detail how you set these things up. And stay tuned during the convention. It's very likely we'll put up additional videos during the convention and even toward the end of the convention. Our C-clamps were specially designed with violin makers in mind, and they feature a fast-acting spindle that can be tightened further. You can set them that fast. The small clamps get up to about 45 pounds of force. The larger clamps a little bit less. They have removable pads in case you glue one to something, or if you want to have different sets of pads with faces, leather faces or something on them. There are grooves in the pads, so you can set clamps, 2 clamps on either side of a crack, and pull them together with twisted wire. The fast setting mechanism is kind of a two-handed thing. You pull the release plates back and slide the spindle. The big advantage is the spindle does not twist when you tighten the clamp. So this kind of a quick setting system really works well for the kind of work that violin makers do. They come in 3-inch, 5-inch, 7-inch, and 9-inch throat depths. The 9-inch will reach to the center of a cello plate.
We're also known for our Endpins, which have a single body clamping mechanism that can't rattle, a lightweight carbon fiber shaft, and a tip that's actually 2 tips, so that you always have a metal spike and a rubber bumper on hand. There's even a little piece of Velcro loop material inside the body, so that the shaft can't fall out all on its own.
Our peg shapers come in 2 sets, one for violin and viola, the other for cello. There's 12 hole sizes in the small set, 12 hole sizes in the cello set, and 6 blocks in each. In the small set, the 3/4 block will fit a peg in a new 4/4 violin. The upper sizes, the 9, 10, 11, 12 block, are for bushings. And the smallest block, the 1/2 block, matches the smaller violin reamers that go down into really small fractional size instruments. The shapers have 2 adjustment screws to locate the blade. This is important. I'm just show this, that you can loosen the blade, move it in and out, reset it, and it will come back into perfect adjustment. To readjust it, if you need to change the adjustment, a subtle turn of the screws, and you can dial the blades in exactly in seconds. The blades in these shapers are now solid carbide. The machining is exceptionally precision, and they're almost the only shapers that actually work on the market. They will leave an incredibly round, smooth peg shank, and you're not going to get jitter and any of the problems you're normally accustomed to. This is what we call a skiving tool, and it has a blade that skives off the remainder on the shank but it also has a little saw to do the undercutting of the collar. So when you're shaping a peg, you can put the peg against the saw and undercut the collar instead of using a knife or some other means. But the really unique thing is that this blade rides on the taper that you've established with the peg shaper. So there's an uncut portion of the peg here, and as you rotate the peg, you slowly push it in to the blade, and you'll skive off the remainder of the shank right up to the collar. And it will accurately follow the taper of the peg and produce a nice round finish. This is a tool that we showed in Cleveland and demonstrated, but we didn't really have it perfected and didn't work that well on Whitner and Perfection pegs. So we redesigned it. What it does is round the ends of your pegs really quickly and accurately. So there's a series of holes in a registration pin, so you can pick the hole that fits the peg and lock it in, and then go in with a tool steel cutter and an electric drill and round the end of the peg. Works quite well. Just a wipe with sandpaper around the edge to get the burrs off, and you'll have a nice polished round end. There are two cutters supplied, one for violin and viola, one for cello. This tool should be ready within a couple of months, and it may have a slightly different base so you can clamp it to the bench. It's kind of awkward doing it by hand like I just did. Anyway, more to come on that. Our disc sander is unique in that it is turned by hand. It's not electric. It has a table that raises and lowers, so you can sand cross grain if you're sanding wood, or you can raise it up, sand with the grain, or if you're doing tool sharpening, you can sand with the edge of a scraper by going to the top of the wheel. There's a quick setting fence, and with a protractor you can dial it in perfectly, and everything is aligned and ground, so you'll get perfect alignment when you move the fence, if you want to move the fence back and forth. One of the main features of the sander is that the discs are removable from the spindle and held on magnetically. You can change discs to change the grit. Just keep an inventory of loaded discs, and they pop on and off. The table, by the way, goes up 10 degrees, it goes down 60. There's a 0 setting set screw for the pin in that position, but then there are holes underneath for lower angles, and you can dial in the angle precisely from 60 degrees, and then by moving the pin up all the way up to 10 degrees positive. The 10 degree up tilt makes it really easy to set the neck angle when you're on violins, violas, might even work on a cello. The mounting post has a base with 3 holes in it, so it could be screwed to the top of a workbench or table. But we have a really good clamping system, and this The way this clamp works is a binding plate. So it will go down to nothing. It'll go up to probably 8 inches or so. Our frog slide cutting fixture holds the slide blank in this chuck. It uses the frog itself to get alignment, and the dovetail angle is set with the rotation of this chuck against one of these 4 stops. The stops are preset at 10 degrees, 15 degrees, 22.5, and an extra one that you can adjust for other angles. The 22.5 is because it's a step on the back side of the chuck. The chuck can be flipped over and you can cut pieces for octagonal button inlay. So the way this works is this upper fixture, part of the fixture floats. It's spring-loaded and picks up the long angle of the slide. So it transfers that angle to the angle of the upper plate and then to the slide cut. There's this micrometer stop here that's graduated, and you can dial in a perfect width. So when you're using it, first you set the fence on the sander to 90 degrees, then you get it set up, and we'll explain all this in another video that really goes into detail. But with 3 tries, and I use popsicle sticks cut up to show people how to use it, you can train anybody to use this and get a perfect fit on a slide. Our eyelet drill fixture uses drill bushings and standard drills to drill the hole for the eyelet and the underside of the frog. It can be used to drill out and bush an old hole. It can be used for new frogs to drill the original hole. The way it works if you're doing restoration or repair is there is an alignment tool that drops in where the drill bushing goes, aligns the frog to the eyelet hole, and then by lightly clamping, the swivel plate can swivel in all directions. It gets the long taper correct in alignment with the drill bushing, and you can align the underslide by sliding the swivel plate back and forth. So if you have a crooked frog, you can get perfect alignment vertically with the underslide. And once it's aligned, there's a stop that you slide up. So when you put the frog back in to re-drill the final hole, you'll be in a perfect alignment. So the idea is you select the drill you want to use, drill out the frog, oversize, take the frog out of the fixture, bush the hole, put it back in, and as long as you don't put too much pressure on the swivel plate, you'll be back in the exact same position. Take the proper drill for the eyelet you're using, and with a guided bushing, you'll get that hole perfectly square. The other thing that these tools do is drive the eyelets in square. And there are wrenches for the eyelet that fit in. There's one for violin, cello, and there's a larger one available with bushings and drills for bass. This fixture is for drilling bow butts, which kind of makes me clench up every time I say it. And it uses drill bushings to guide special drills to bore out bow handles. You get alignment off of the underslide, so the hole will go in dead parallel to the underslide when it's clamped in properly into the fixture. Let's see. Just do a little demo here for how to set it up. So when you get the bow seated properly under the plastic caul, and clamped, the drill bushing holder, this piece on the end, floats, and with a spring washer you can set the tension on it so it will stay snug, tight against the main body. And these are precision machined surfaces, by the way. And then with this alignment tool, you go in, find the center, you center it on the bow, hold some tension on it, tighten this piece, and you've got perfect centering on the end of the bow. You've got perfect parallelism with the underslide. And then with your drill bushings, you can bore the bow out in 0.5 millimeter increments. The drills go up to 6 millimeters for bushing, and down to the screw size of the actual screws. And so once the bow's bushed, you take it out, bush it, you can put it back in, it'll have the same alignment exactly. Go in with your screw diameter drill. And we also have step drills to get the pilot, the nose hole for the screws. And they'll be piloted not only off the bushing, but off of the shaft itself. And they will be dead center. The drills are sharpened more like boring bars than they are drills. And to resharpen, you just bump them on the grinding wheel if you ever needed to resharpen. These have more of a point on them, but again, it's just a very simple procedure to sharpen. This piece is just in case people making new bows want to align to a center punch mark or a pencil mark or something. You can go in with this and hit a mark. There's a second clamping caul for base bows, so you can get everything you'll ever need in diameters on bows. There's enough alignment and clearance for anything you should encounter. Our plate drilling depth gauge allows you to precisely adjust how far down you drill into the plate before carving, so you can get a pattern of holes to carve down to. Most of you are familiar with doing this. And it attaches to an iron drill press table with very strong magnets. They're hidden in here. And to use it, screw the body up 5 or 6 revolutions, 1 millimeter per revolution, so you're past the thickness you want to adjust it. Then slide it over under the drill. You want to set the depth stop on your drill. You bring the drill spindle down against the depth stop. So you've got some travel. Get it centered, roughly, and then screw the body up until you have no clearance to the drill point, clamp it, and then turn the numbered ring here until you're zeroed with this dot. Now, you've got your depth stop set. You're at 0 clearance. Then at 1 millimeter per revolution, or a tenth per mark, per number, you can accurately dial down to the plate thickness you want and drill down. This is good for violin, viola, cello, archtop guitars. Bass plates are really too heavy for it. We don't recommend it. There's a chance you might be able to move it. If you have any reservations about it moving because you've got too big a plate or something, you can set some clamps on it and clamp it to the drill press table.